I'm John Sasser. I'm Vice President of Operations for Sabey Data Center Properties. We are in Quincy, Washington at our Intergate Quincy campus. What we do is we build out data center campuses. We lease out the data centers to various customers, and they come in, bring in their technology and run it. So our primary interest is making sure that we have highly available, very efficient data centers for our customers. A significant part of our overall efficiency and design of the data center is utilization of hot aisle containment. Our data centers typically don't have raised floor, and we use hot aisle containment to be able to raise the temperature that we bring in the data center. So in using these efficient technologies, you can extend the amount of time that you don't have to use refrigeration by raising the temperature that's being discharged from the unit. So instead of having to discharge temperatures that are in the 50s, we can discharge temperatures that are in the 70s. And so obviously we're able to economize for a longer period of time. So we use hot aisle containment to achieve that. What that does is that eliminates the mixing of the cold supply air with the warm air that's coming out of the back of the servers. Instead of that mixing occurring, that warm air goes directly into a ceiling plenum and then to the air handler equipment. So we require hot aisle containment for our wholesale colocation customers. We've used different kinds of pods, we've used different kinds of cabinets, different kinds of chimneys. We're very flexible there, but we always use some form of hot aisle containment because it's just the right thing to do. We believe it's the most cost-effective way of cooling the data center overall. Hot aisle containment is very effective. As most people know, cooling takes up a good portion of the energy that's used in a data center, and we want to be as efficient as possible in that. We want to keep the temperature at a range that is best for our customers' servers, but do it in such a way that uses the least amount of energy. So here in Quincy, Washington, we have a very good climate. It's very mild. But we have more outside air concerns than what we have in Seattle because we're in a rural area. There's a lot of agriculture around here. Some of the farmers burn their fields, they plow their fields, you get dust, that sort of thing in the air. And with indirect evaporative cooling, essentially you have two different airstreams. You have an airstream inside the data center that gets pulled through one side of a heat exchanger, and you have a separate airstream outside the data center that never enters the data centers. And you can evaporatively cool that air in the summertime or whenever it gets above a certain temperature so that you don't have to turn on your mechanical cooling until kind of a last resort. So we don't have to turn on our mechanical cooling until the hottest of the summer afternoons. Otherwise, we're either running through a dry heat exchanger or we're running through a wet heat exchanger with evaporative cooling. If there's dust in the air from a farmer, if there's smoke in the air from fields burning or whatever may be going on, none of that gets into our data center. We're keeping our servers cool and we don't have to worry about contamination. The other thing that this design has allowed us to do, when we were looking at it, we were able to reduce the size of our generators. So we didn't have to install as much mechanical refrigeration as we do in our typical data center. So instead of installing 2 megawatt generators per our original plan, we were able to downsize those to 1.5 megawatt generators. And that means we were able to downsize switchgear. It means we were able to downsize copper feeders. So we were able to save copper and save capital costs on our electrical installation that helped in the overall build of the data center. This summer, actually in July, we commissioned the second half of our co-location data center here at Sabey Data Center in Intergate, Quincy, and we saw a PUE of 1.25, and we really commissioned that data center hard. We had fan units that were simulating servers to make sure that we were actually running these units at full airflow. And very impressed. We were not expecting to get 1.25 on a hot July afternoon on our PUE, and we saw that in commissioning, and I think realistic commissioning. The Munters Oasis indirect evaporative cooling unit has exceeded our expectations. We've been very, very satisfied with both the air handlers and with Munters as a company and supporting their air handlers.